Hello everyone and welcome to this new stream of EagleFly, the experimental debugger. Today we will continue on implementing what is the first call to our debug system that basically is called the debug callback or debug tracer callback, I remember. And what basically that does is just is the one in charge of receiving all the debug events or messages, as we call them, and do something about it. Do something with it, capture the data, and process it. So I think that's what we'll do and continue today. If you have any questions, please feel free to ask them after the stream has ended. And yeah. So okay, so let's start with this. I will open for coder. I will compile to see what we left off. There you go. And if you think about it, I mean, this little thing here is the one that takes a lot. I mean, this is not part of the project, but I was just looking at, and the thing that takes a lot of a lot between several things, but one of the things that takes a lot of time to load in Visual Studio is this little bar here, which is it's a kind of tracer. It's the one that is used by it's a kind of, I believe it's all the calls. For example, these are all the calls in the project. If I go load DLL, but here are just the ones inside this CPP, I believe, because there's no other one. Or I don't know, but man, that should be nothing. I don't know how it goes with these things, but if you can see here, we have memory arena. This is something. Okay, so we have a memory arena here. I don't know if we use it at all, but nope at all. Alright, so whatever. So the point that was that we started this process, and we start running it, we initialize the process, and we start to process each if debug event. For example, this is create process. That's basically the first one that gets called. Continue debug event. This is one that we don't process at all. Continue. Then there you go. We start the window. This is the process itself, and next start, because that's all we got. And we have it has the name itself, this it has and that's curious because we don't have the name, or it seems that we didn't have it in the process itself. We have to check it back. I don't remember, but we have it here. And this shows the name. Well, no, it's not the name, but the image file name. And this is, for example, a debug event, an exception, where all the exception handling events happen for the process. So let me see if I don't know what was that. I can go to this, and this is the output of a string, the one that we set into the project. I can show you. Is this one right here? I mean, which basically is the only thing that we have right now, amongst many other stuff, but we can start like dumping all the data that we found out, and we have that, and we say, hey, it's Unicode, because we don't want to process Unicode strings for now. Don't process me at all. And then we got the string length, that's 16, and then F10. We malloc it, we read process the memory, read the process memory, and we output the buffer itself that says hello from test, and hello from test appears right here. So that's nice. We have now one one thing that the debugger does, that's dumping out. I mean, if you see all this stuff, all the modules loaded, all the if you see, these are all the DLLs. I don't know if you can see it, but let me put it right here. All of these guys are basically, they are reprocessed with the event of on DLL was loaded, for example. So these are all DLLs, and we say, oh, on the output we can say something like this: all the DLLs loaded, and all the data that was loaded itself. So we can do that. I think that's nice, and we can dump it. We can dump it for now right here, or yeah, I think between later on, when we see how all this goes, we can start connecting all the data to the Windows stepping, to the window display. And sometimes that's the way it goes, because one of the important things here is that this part, I mean, I just see here the other loads, but probably it's because that's the only thing that has happened. But I mean, the output also prints other stuff, I guess. For example, in modules, well, I cannot see here. I mean, these are the modules for this process, not for the other process. But we can see the modules here, the threads, the registers, the memory. These registers, well, we have extra registers for depending on the architecture and what we have or in the hardware itself. We have the memory and the watch window itself. So yeah, I think we can start by dumping this module list. Let's see how can we do that. So let's go back to the, well, and if I continue, 5, we create threads, and these are not threads that we created. It's more like Windows creates all those threads. As you can see here, we can check what's that, because this is the handle to this new creation, and this is the local base and the store address for that. And it's like basically, I mean, for example, we right now have two DLL threads working and our own thread, you know, that's the debug tracer callback. This is our own, this is the main, and these are two DLLs, that two threads that we didn't create it, but the process created as well. And it's something that we can also dump, I guess. 5. So you see, we close the window, we also exit the process, and that's something that I want to assure, because even though the windows is closed, well, I believe that's the process, yeah. But let me see how can we handle that, because we also want to handle process exiting and all that stuff. So let's see what we can do. If we go to Win32 EagleFly and we go to debug callback, here you go. Let me put the charger on. So yeah, so we have this kind of this thing, you know, where we create a process, create process is gonna basically, well, we have just this for command lines, but this is just kind of stuff there, because we probably don't want to do that way, I guess. So let me see what we can do. So we have all these events that we should process and should get some data out from it. For example, there's one, look at this, exit process, for example, and exit thread. Well, I'm gonna do all this stuff, you know, because we're not. And let's see what we can do with this. Let me put seems reasonable here. get the file size. Okay, so let's see what we can do. But let me output debug also this data. No, this not. And sorry, hold me a second. So here we go. So let's see what we can do here. We have the debug info that basically has everything there. Well, I'm sorry, not everything, but the data that we were looking at into the for example, the file, the handle to the process, the handle to the image file, and everything else. So for example, what if we do something like this? Oh, okay. Now I understand, because the process itself can change the thread context of their own threads. Uh, we should get thread context. Let me go. So let's see what we can do here. We can pass it right here with the ptbug info. Because we already have process info, isn't it? And this is like process debug info. Well, it's because when I see the P, it's like pointer or something. Pointer to debug info. Well, it's not so different, but it's not a pointer. That's all I want to say there. And I want to get a context, so I want a context. Main thread context. Why not? Alright. We can try to get the context, and then with the context inside we can gather the instructions. And what I'm gonna try to do now is to gather the thing that we couldn't do the last stream, was to display the first the instruction that we're executing, or well, the set of instructions. I don't know, but, this set of instructions that we're executing, so we can have a data flow of instructions, and the registers, which are the things that the instructions are operating into. So if we have those two, we have like this kind of, I want to display this kind of table of instructions and registers that we are executing. So I mean, basically building the binary, or building the assembly, building the assembly instruction set. So what I want to see here is, we would like to define a way to get the proper context. So let me see where can I found this. How can I do it? It's in Windows.h. So we have here, and we can go to okay. Can I find here something about win? How's it called? How is it called? Win and team. How can I find a file inside? Where are you? We are in Windows Kits, Windows. Can I find Win? Oh, here you go. Awesome. Awesome. Let me open with Notepad. Why not? Let me close all this. Okay, so we have WinNT.h. It was pretty much faster than I thought. And here I want to find the, or let me open with full color, because why not? Why not? Why not? Let me get the path, place. Oh, and this is the call to the shell. Okay, Windows Kits 8.1 include UM. There you go. I'll copy that. I want to open, well, I cannot copy in full coder. See, and Windows Kits 8.1 include and here is WinNT.h. Here you go. So this is a file. I want to find how is it called? ARM64 anti-context. Well, context. Okay. This is the EM context structure compiles with x86 programs. TVD should this be for all architectures? That's my question. For we define a 128-bit structure and use decal spec line, fragment line to blah blah blah. No context. I want the structure. Here you go. We're getting somewhere. X state context. here you go. Context frame. This frame has several purposes. It is used as an argument to anti-continue. It is used to construct a call frame for APC delivery. And it's used in the user level thread creation routines. Alright, this is what we want. The number 3. The flags field within this record controls the contents of a context record. The okay, so these are the registers. These are the basic registers, cool, with context integer. We have context segments, so this is the data segment, I think this is the instruction segment. This is a file segment, I don't remember, but yeah, these are these segments. I believe there's more, but yeah, because there's D, E, F, G, A, B, C, D, E, F, G, H. I don't remember. Context floating point. Oh, okay. So these are for XMMO for SIMD operations. Registers. XMMO 15. Context debug registers specifies DR0, DR3, and DR6, and DR7. And these debug registers should assume they are the ones that we get by default. Register parameter home addresses. They have these typos. Jesus Christ. Okay. So these fields are for convenience. What they meant with convenience. They could be used to extend the context record in the future. So I mean, this probably is going to change. So that's we have to take real consideration about this thing, because probably it's not going to work in the future. Well, we don't need these ones, but we need the segment registers and processor flags. These are the E flags, good. And we have the registers. The integer registers, rax, RCX, the program counter, IRP, and probably with IRP, only if IRP has itself the counter of the, I don't remember the instructions call, or the number of instructions set, floating point state, XMM save area. This is for floating point, alt XMMO. This is an M128A, good. This is a Dwarf 64, which is good. This is a word. And these are vectors registers, which I believe are the same as this one. It has a save area 32 floating point save. It has vector control. I don't know what's that for. Special debug control registers. Okay. This is cool. We have these things. We have debug control, last branch to rip, last branch from rip, last exception to rip, last exception from rip. Okay. So we have something to play around, you know. Select platform specific definitions. So yeah, I mean, I don't know if this is what the thing that we're gonna get, but we can get it because it's called the context, so we can get there. But I don't know if, I mean, this is for x64, I believe, because I don't know if they say another stuff for another, because this is WinC, this is the dispatcher context. Establisher frame, target IP, context record, language handler, the history table, scope index, field 0, dispatcher context, define exception filter, and termination handler function types. What the hell is this? History table, exception routine, context record. That's the one that we had before. That was for the no, but that was the exception recorder. It's different. But it's a pointer to a context, so probably it's a context. It's a context. The scope index, this is interesting. We have the scope index. So like in the stack for each thread. We have the history table. Do we have something with that thing? This is one. Oh, cool. So we have here everything. I mean, well, no, I mean everything, like by everything, you know, but we can search the context, and the context is gonna have where in the stack it is, how many times the stack has been unwinded or rewinded or whatever. You know, we have a count. I don't know what's this for, but it's a hint. Okay, so before going the route of that, let me see if we can display this stuff a little bit better. So I was just, oh, let me before going that, because I was just like thinking, well, let me do this, and we were right here trying to do this. So let me see, what can we do with this? I don't know, basically we're gonna get this, yeah. So now I want to open this file again. Let me get this baby. Boom. I don't know if we want it there, but I can. There you go. So let's start by displaying these registers. I can use the same function that we were doing before. Let me see. Let me see in and I wanted to basically do the whole thing, you know. This is let me go specifically to this one and say and probably I mean at the first time we're not gonna get too much about it, you know. So probably what I want to do instead it's something like this. It was here. And I want that. Probably this one. And where is buffer? Here's the buffer. So we want the some handles, a bunch of handles. I will imagine, I don't know how many. So probably want a linked list of handles, you know. Because if you think about it, well, we don't know how many it will be. Does this tells us of which thread we got it? Let me see. We have exception address. The only thing that I don't know how to get here it is, and we have here, I mean, these are the registers, but it's not in memory, you know. What I want to get is the instruction pointer. Where can I get that? Let me see. Okay, I will since we will need the instruction pointer, we will need to look at it first. So before I go that route, because I know that it's gonna take a little bit more time, but you know, I mean, I wanted to see like what was the structure of this kind of of, of, of pacing. You know, it doesn't matter. We're gonna get to it in a moment, but the first thing that I would like to do is to gather up all these things that we have here. You know, since these ones are relatively easier, I'm sorry, to handle. Let me see. So we have the processing of debug string event, which basically just outputs a debug string, which is the same. We have process debug event, and we don't know what to do there. Oh, it has the exit code. Okay. So yeah, we can do that. So we can get for the exit code. Debug tracer callback, and here I want to have something like that, and something here like, well, we probably we don't need this anymore because we already handled it. We can close the handle for the process and for the thread that we have. And probably well, I believe the process itself is going to handle the closing of their own threads, isn't it? Yeah. I don't think so, because there will be call. I mean, when we exit the process, like here, we know that it's gonna exit it. When we exit the process, all the threads they're gonna be, or they should be closed as well. So we can do something similar here, you know, like we can have was more similar to the other. Where is it? This one. Here. This we can use. We can do something like this. We can say the process exited with code blah. I don't know, we can do something like this and then p execute. So probably we don't need to do this, but whatever. Sprint buffer right count the process exited with code blah execute blah blah. Then we print the code, so we could test that. And let me first install this part process, and then pxe code. Oh, you don't find this one because it's this one. And then here exit process debug info. It's just debug. You don't find smprintf. I believe it's like this. I don't remember. I don't remember. So we can use, I believe, this is a template. We want to use the template, so we should use this one. And right now, I don't want to do anything with this. Let me see. Alright, so let me see what happens with all this. And I don't know, do we have another process here? Invalid code path. I can do something like this. Just to assert that we are processing everything and we don't have anything. We don't have invalid code path, but we can define it. I know we want that to be, I mean, it's something that I can define on the platform layer, but I don't know. Okay, so I want to go to my stuff, and we are in the other process, so let me change to the correct one. And you know, something I hate about this debugger is that I mean the breakpoints are totally wrong, you know, whenever I modify it. So they don't, I mean they're based on line, you know, and instead of instruction, you know. It's just kind of busted. Which I probably understand because you don't know the instruction until it's wrong. But I mean, even the debugger can or should handle it a little bit better, you know, so that you don't have like this kind of weird scenario. I mean, because you know that you will always modify the data, and probably you want to keep it. I mean, instead well, I don't know, but I mean they're totally wrong, you know. But because what I want is a breakpoint on the instruction, not on the line of the file, you know. It's like this is the instruction I want to see, not the line, you know. So whatever, I think I can do, I don't know, the letter breakpoints, Control Shift F9, Control Shift F9, and that didn't work because, you know, why should it work? Well, whatever, my friend. We don't have that, and I want to set a breakpoint again in here, right there, and I want another one right here. I want another one right here. We will do that in the next. Oh no, 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 Jesus. This is not gonna do anything at all, but whatever. I want another one here, one here, one in there, alright, so that seems fine. There you go, we get the and base of image is that. So well, we do that in a moment, but so yeah, I won't care too much about that right now. So you see, I mean, I cannot even touch it, you know. It's not the process address space for my process. So here appears like, hey, what the hell? So yeah, we have to take that into consideration to when we want to access it, because yeah. Continue. We have an exception. We continue. We have an output debug string. Continue. We have a create thread. Yeah, we continue. So what if we end the process? We didn't get anything at all, isn't it? So it's not like the exit process is not continuing. So this thread got here, So yeah, so it doesn't seem to gather anything else for us, at least right here, because even there, yeah, I mean it's not here at all, isn't it? Oh, it's waiting. Oh, I got it. I got it. It's waiting because there's not this any signal anymore. That's interesting. So let me check for this. Uh, 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 uh. So I think that what we can do before going into the exception line, let me finish doing processing. I mean, at least just dumping the data from here, to see what happens. So let me go and see. First of all, we would like to basically do something like No, it doesn't matter. So we can do something like this for now, so that we can check if it's running and finish the processing. Okay, so now what about all these ones? We can go right here. Let's see, we can dispatch this one also. Well, I'd like to see if this thread is the same as the thread that we created back on the next one. So let me see. We can dump this data out just the same as we did before. And do something like this, and then say thread blah thread 0x id, blah was created at base address right here. We'll get new thread a thread, new thread, start address, size T, and we can get what's the next thing, the start address, the ID. So the ID should be, how can we get the ID? The ID, it's into it's in the process info, isn't it? Because here we have handle to ID. None of this has the ID itself. So we can let me see. Oh, it's in the debug event. Yeah, I remember. Thank you, Mr. Webpage. Oh yes, so continue debug event's gonna close the handle. So for starters, I would say that we want to it's not this here. Let me see if I can find. This is the one I was looking for. Let me see if that, I mean, we can use P, I guess. And okay. Let's see if we can see that right here. I just move everything, and this is the same. We create a process, we don't handle it right now, so we can go to the next one. Then the exception, we don't handle it right now. The debug string, hello from tests, and then we should what's the buffer? Okay. Okay, that's nice. So we can continue. I want to format this a little bit more. So neither the, nothing has continued because we have not done anything to advance the pointer, you know. So that's it. We want a proper way to advance from instruction to instruction, you know, and that's the next thing. But for now, let me check all this. Let me first, where is the debug string? This one, and this is I guess well, probably this needs another like this. Probably, I mean, we want to take, I mean, we don't want this smprintf right here. We should implement ourselves our own print function, but for now it's okay. I want to put a to do somewhere here. Implement function, implement printf function ourselves. Is that how it's written? Ourselves. Yeah, ourselves. Okay, so now we can basically do the same thing. Well, now before doing this, let me just I just wanna do this just for the sake of sanity. And I don't know if this adds it on. I guess now that I think about it, it's not gonna do it that way because it's gonna print to the, it's gonna refill it. So probably what I want is more like this: buffer plus bytes read, string size, I guess. That will move me up to the -1. This is gonna be, I mean, it's totally cheesy, but it's just for getting it right, you know. This is car. We don't need this anymore, and car equals to this carriage return, and car plus plus, it's going to be, oh, I probably didn't want to advance anymore. I probably want some kind of better doing this thing because we don't want to do it this way probably. So it's more like that, and then you can say if strings, well, this is a malloc, isn't it? Well, it's a malloc, so it's okay. But just because it's a malloc, but I mean, even if it's a malloc, doesn't matter because we don't know how big does the output debug string is gonna take, you know. So probably we want to do something like to do prevent from, well, test for different output debug string sizes, because we don't know. I mean, basically this thing can do, I don't know, bigger things, you know. So I don't know if we want to, it's more like, do we want to set a limit size for output debug string? So yeah, probably, I mean, this is wrong because we allocated just the size that we needed. So probably we want something like some buffer, extra bytes. You know, we can say extra bytes equal to 10, 20, I don't know, just to have to prevent from running to wrong locations, you know. So let's see, we have an exception, an output debug string, hello from test. We created event, there you go, with that ID, perfect. And then we continue. Alright, that's good. And the one of the exit process, well, we have to handle it also. Let me we have it right here. This is the create thread one. Probably this wants to be like this, just for checker one. And let me see what does the create thread. Let me go back. And the exit code for the thread. So yeah, probably we just wanted to process the exit code, I guess. Probably want to cache the thread handles, and the well, this is the exit code and the exit thread. And this is from the debug event. It's a thread exit code, thread ID, and the handle. don't know if we want this to be, yeah, probably, yeah. And this is new thread, blah blah blah. So we should only create thread one. We can do handle and do add handle to list, add thread handle, and we can pass this, I guess. Can do something like that, and then we want to probably now want to process the others. So how do we want to know which one? We know the ID is the same, isn't it? But the handles are different. So we probably want to pass basically out the event, and we want thread. And probably also we want to pass some debug state here, yeah. But probably that's for later, I guess. But I'm starting to see here the patterns. I want debug state. I want to have the debug event. So yeah, because we want to know how many handles we want, so we probably want to do this, and we want to, well, yeah, I think this is the way we want to do it. We want to do it probably like this, and then we pass it, then we compile. And then here we have a new thread. Probably I don't know if we want something like this with from ID. Because I don't know how many I mean, there can be any threads, you know, like any number. So let me see. I mean, probably we don't want the handles itself, you know. It's kind of crazy. Because we don't want the handles. yeah, we don't want to store the handles in the debug state. We probably just want to have like a more ordered way to modify the data in a process, you know. So let me think about that. mm, mm, mm. So hold me a second, I would turn on the lights. So yeah, I mean, yeah, we want to have the handles so we can gather the data, but it should be just for the platform specific code. You know what I mean? And also, I mean, I would like to see, because we have a ThreadID, you know, and ThreadID, I don't know if we need the handle itself, you know, because the handle is the one that we need to basically attach to each one, and open and read, you know, because that was the thing that we saw here. Yeah, probably. Yeah, like this. Probably we want to. What is it? Process debugging as a thread. Yeah, so we probably get thread from ID, and we have the ID. You know. Something like that. So probably it's more like this, you know. Where is it? At get thread from ID. And this is gonna pass. Come on. Thread, there you go. There you go. Probably want something like that. And probably this is like a Win32 debug state or something. Win32. Yeah, Win32. Yeah. I mean, I don't know if we want to call it. I mean, because we have a debug state, but now that I think about it, I mean, this is a debug state, so the other is like the output state thing that, or probably want to differentiate about the debug state and the tracer state. Probably this is tracer state. Win32 tracer state debug blah blah blah. Yeah, I think. Yeah, because if you think about it, I mean, the tracer state is gonna be totally different and from the debug state. I mean, if we wanted to separate that notion, we will have like, yeah, the tracer state is gonna be the one that we can call it tracer, dispatcher, or the Win32 dispatcher state. I like it. Dispatcher state. Dispatcher state. It's a little bit long. Dispatch state. I like it. Win32 dispatch state. Okay. Yeah, and this is totally independent from what the debug state and how it controls it. I like it. So we have like these two notions there. Cool. So we probably want to do something here where we have a Win32 state. We have a Win32 state, but this has I don't know if we want to use this one, because this has the callback, it has all this handles, this is all for loop like code editing. And we can have it here as itself, which I don't know if we want that or we want to defer it. I want to do something different here with it to dispatcher state, because yeah, I mean, we don't want it to be there with the Win32 state. So probably what we want is something like this, and a typo there. So this structure state is gonna have basic table or basic map that's gonna have have a H process probably, and it's gonna be, I don't know how to call it, but ThreadID map, and probably, I don't know if we want to do thread map, ThreadID map, probably want some ThreadID map. And this ThreadID is gonna have just basically thread handle and the ID that I believe is a door. It's a door, yeah, it's a door. And we could do this, and this can be 2096 thread ID map. Probably want something like this. My question is, can a thread can have multiple, well, it can have multiple handles? Yes, it can, but it's gonna have just one ID. So we probably want more like a hash table, you know, which is so we have it's more like this and more like this. I believe, because we can have multiple handles, and probably something like that. Okay, why not? I like it. And that way we just need to handle it to get the one that we need in the ID, I think. With the, in the case of the ID. Alright, so yeah, what else? We think I can go to the next one. Probably we can do something like this, guess. and we can do something like that. Let's compile. And the first thing that I want to do with this 132 dispatcher state is to define it into the 132 here, so we can have it so 132 dispatcher state, this state, and this state H plus, well, it's gonna be no other thing, I guess. So we just pass it, you know, and probably dispatcher state probably can be something like input data and output data, you know. It's gonna be like these two data flows coming on. Probably, I don't know if we want to separate it later, but for now I think it's gonna do it. Input data, output data, and we have what's called, we have, let me move this here so we know that it's about here for the dispatcher, and let me dispatcher states, dispatcher structures, 132 dispatcher structures, there you go. And let's see, we had another structure here that I was trying to look, that was basically the first idea that we got for the input data stuff. Where is it? Where are you? I cannot see it, man. Oh, is this one? Is it? Is it tracer input data? And where are you defined? Here. Let me move this right here. 132 EagleFly. And I know, well, we have a tracer input data. Okay, we have something like that. Yeah, it's good. So the thing, I was thinking, like, how can we handle, I mean, do we want to like allow to have like his kind of a queue of inputs, you know? Probably we have to do Alex provide a user input data queue, so that instead of having this long data structure, we can pass like multiple requests, you know, because this probably is gonna convert into our request system later, where we like have this adequate like input data processing, which is kind of a it's kind of a thing, I guess. It's kind of a thing. For now, I'm just gonna leave it right there, but yeah, provide user input data queue. Let me put it here. Yeah. And let me go here. So we'd like now to define that the place where we have it in Win32 dispatcher state, and this is basically the disk state. This state trace the data, we'll have it done, and we have and this is input data, command exe, blah blah blah, run from CMD line. This is okay. This input data, something like that, and this is ThreadID. This is not here. This is for this, and this is our own ThreadID, you know, that we probably want to handle later, and something like this. Probably there you go. And the thing that we want to pass here now is this state. There you go. There you go. So now we can come back to the place we get it, and this is now Win32, where we can have, let me see, this is input data. There you go. This is input data, tracer data. This is this state. Well, I don't know. Introduce something like that. Something like it's gonna be in state the Win32 spatial state, and this is this state input data, tracer input data. There you go. And then we have a startup info for the process. We initialize it, and we can do something with this that we like. We can just do one and define the commands, which I think I would like to do it. So let me do it, because why not? So probably it's more like this, you know. Oh, where is it? Oh, yeah. Oh my god, it's this one. So probably it's more like this, and this is gonna be, so this is the target. We can have a this is gonna be there, and this is gonna be like that. Like that anymore. We can do there, run from command line with exe. It's gonna be that, and the data cmd.exe.fullpath is gonna be target fullpath, and then this can be here, target fullpath, and this command line. This is gonna be data target fullpath. Oh, this is data target fullpath. There you go. Command line.exe, and this is basically all the same. Probably I don't know if we want to do this like that, and we can pass it right here, target fullpath, and this is the command line.exe. Well, probably this is the command more explicitly. This is the command. Oh no. Where is this command coming from? Oh, this is the command. This is this can be called this. And then this is the command explicitly. There you go. Yeah. This is the input data. Input data. And this is gonna be fine here. this is gonna be oh, 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 oh. Why do I have pxe code and etc code? Okay, let's bust it. We don't want that. We don't want that. Create process, something like that. And we can say something like this. And okay, command blah 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 blah. Make a podcast because I don't know what's going on. This is, how do we call it? Deep state. This state dispatch. Okay, this state. This state and that blah blah blah. And this is gonna be the exe code. Get thread finally. Don't worry about that. This is the exe code. That's because this is the process, isn't it? So this is the process exe code. Process exe code. Yeah, man. Yeah, that was the thing, isn't it? And this is the thread exe code. So this is gonna be like this, and this is gonna be like that, I guess. We don't need the exe code, I guess, for now. So I'm just gonna display it, that's all. But we want the process exe code, probably, yeah. Process exe code, as you know, let me put a note here. Well, where is it here? Note. Right now we are only debugging main process, no shop processes. Okay. Continue with this. Well, yeah, I know that thing, I know the thing. And this is not, this is a comma. There you go. Let's create the clear identifier. Oh yeah, that's the thing. And this is the, it's not called exit thread. exit thread. Man, I'm looking at this right here. Oh, it's because it's you. It's you. There you go. It's not a member of exit thread, debug info. Okay. It's the W execute. Okay. The W execute. Okay, and now we just have the get thread implementation, which we can do it. And basically I'm gonna, well, this is more like this. This is this state, and there you go. There you go. And probably I want to call it, well, let me put it right there. And we want ID. And a handle. Probably and basically I believe we have a way to do this. We can say something like we have an ID, and that ID is going to be basically our bucket. Probably want this more like this, and probably we want to, I want to call this thread from ID. There we go. This is gonna be the bucket basically, and we want to get this state. I don't remember ThreadID map. ThreadID map. Some ID. Shift by. It's 4096, so it's 2 to the, let me open calc. The logarithm base 2 of 4096 is 2 to the 16 is 5 to the 10 to the 924, so it's 2 to the 12, 2 to the 12, 4086, so it's 12, so it's more like this. And it's well, it's more like this. The 212, it's 12 bits. Four thousand 95, 4096, it's 1000. 4095, it's FFFF. Okay, so this is the one we want. And this is probably one not like this. Oh, we can do this in steps, you know. Well, probably it was okay. It was more like this, but this is more like this. And this is more like this. And probably we want to have the always present per hash function, always has to be there. And this is gonna be you probably want to well, now think about it. Well, we don't probably care too much. I mean, for ourselves, we're not gonna get another handle rather by, or I mean, at least we should not. We should get just one handle, and just one handle. Well, that's not probably true, but I mean, we're not here talking about a generic handle identifier or handle manager, which I mean would be something. I mean, it would be something cool or important to have. For now, I think we don't want that genericness, and we just want to treat this like like if there's a map, a simple map, you know, so we can be something like instead of this, something like this. Yeah, I like it more that way, simpler, and it's gonna be more like yeah, something like that. And so this is gonna be more like can be something like this, I guess. And we can have it in line, you know, something like it's gonna be something like this, I guess. We can do item handle to the thread, and we can do something like iter id equal to the id got it, and something like that. And so we continue until we it's gonna be like a RAM buffer, you know. Let me open this so you can see how we're gonna do this. Where is Milton? Mr. Milton? Mr. Milton, where are you? Here. So what I'm gonna do is something like this, you know. We're gonna have a map table, It's gonna be ID map. And we're gonna do an inline insertion, you know. So we're gonna look in the hash and the place in the bucket that we should go. We grab it, you know. For example, it's gonna be here. And you know, if we wanna, for example, we wanna set it, what we're gonna do is like, oh, this is the place where we should do it. And I don't know, if it's free, we're gonna insert it there. If it's not, we're gonna insert it in the next one, and so on. So it's gonna iterate in. So if it gets to the last one and he doesn't find it or finds a place to get it, it's gonna come back into the place store. And the only thing that we have to check is that if we get to the same place that we started, we break. So probably what we want to do, something like something like that. Well, the thing that I erased, it was good, so this is the base, I guess. And ThreadID map, go either equal base. Something like that, and then we can iterate through it. So if iter and so we can do something like if handle. So let me do first the look for the search, and then I'm going to do the insertion. So if iter ID equal to the ID, we got it, and we break. If iter more like we have a counter. Well, basically it's the bucket, isn't it? Well, you can say that it's the bucket. So we can look for the bucket itself, isn't it? So we can say like if the bucket it's greater or equal to bucket greater or equal to array count of this state thread ID map. we say, well, table index equals 0. If table index equal instead of here table index, we can do bracket. I think that's good. Instead of looking for addresses, and then we can say something like the handle and here instead of doing this, we can say plus plus table index, and then we can say here like either we can even pass this here. It's gonna be base something like that. And this is table index. And of course we have to let it do it once, so we have to do something like this. So we do it once and we let it continue, which is nice. And then we got the bucket, the result, and then what we have to do, return result. This is for the search. Now for the insertion, is going to be per something similar. We can do if either handle and either ID equals to invalid handle, or probably either handle, I guess, invalid handle, probably like this, I guess. And I don't know if also, or probably I can do is invalid map. It's invalid map, I guess. Can do C, we can do this, and we can say something like handle Well, now it's not a hash function. I'm so sorry, but I don't need you. Okay, so handle, I wanna say that either handle itself it's gonna be equal to handle, and either ID is gonna be ID, and I think that should do it. We can return itself, but so equal handle. I don't know, could be. The important thing here is just that it's invalid map. There you go. We break. And there you go. ThreadID map is not a member of, how is it called? There you go. It's invalid map. Handle is not a member of ThreadID map. This is each thread. And this is gonna be each thread. There you go. It's invalid map. ThreadID map. There you go. So this is an invalid map. We can do it here. Oh. And this is gonna be if we choose invalid map, it's gonna pass 32 32 ThreadID map. Probably this is 132 ThreadID map. This is 132 ThreadID map. So this is gonna be just basically we can test for valid map, I guess. Map handle and map. Oh, ID, I guess. And then we can test that. Is valid, yeah, and this is not there. Okay, so yeah, we wrote a bunch of code there, so let's see what we got from this. So let me see, let's go back onto the place where we were inspecting the code. We have this, although we're not gonna be able to test it. Well, we can test the implementation so we can see, but the exit is not gonna be passed because we are not right now letting it go, you know, or we are not processing, or we're not advancing the pointer, I believe, or we are not processing something, I guess. example, let me see. We can start, and that creates a process. We don't do anything special with that for now. Then exception, we don't do anything. The output below string, we do. We create a thread, we can step into there and see what we get. The bucket is gonna be 156 because ID is something, and we got it. So that seems fine. 4095, and then we can continue with F10, I guess. Get a table index and the iter. There you go. We can continue. It's null, so we have a thread, I believe. Yeah, and this is gonna be valid, I guess. This is gonna be result is false. Alright, we're gonna get the ID, the thread, and we set it. Oh, no, there you go. That is that thing. We're gonna break. And also I missed something there, but let me finish with this first. We get it. Continue the boogie band. Well, let me do it because we just want to allow one handle per ID for now, because that's the way it goes. Oh well, I don't know if we can leave it that way, I guess. The only thing is that, where is it? Right here. We will need to probably, we don't want duplicates, that's the only thing. So it's invalid thread, it's we probably want to and probably we want to do this and this, and either it's different to ID and either handle is different to handle. So we don't get duplicates, you know. Oh. And we can do something like this, so if we know that there's a duplicate, we don't go around, but I'm gonna leave it right now that way. So it's gonna iterate. If we want to insert a duplicate, it's gonna iterate through the whole round. It's not gonna get anything at all. So it's not gonna insert it. Well, oh yeah, but yeah, because if we let's say we found a valid one, I mean, yeah, probably it's not duplicated. It's more like the thing we want. And 32 is not ThreadID map. And it's basically gonna be the same as this one. And this is gonna be something like this. And this is gonna have something like this. And this is like this, and this is like this, and this is like the result. And this needs to pass the ID and the handle, and there you go. And I don't know if I like it. I mean, I'm more used to do it that way, you know. And it's the same. And so yeah, we got the result. So now we can do this and say we have the iter and then ID and the handle. I know I like it like more like with this is duplicated, you know, something more like this, I guess. And something more like this, and we just copy this right there, and we just break instantly. And the reason is because yeah so probably we can do it inside, so we just make one check. I mean, we can do something like this, I guess. And this, we pass it right here. And then like that. There you go. I think that's better. If it's a duplicate ThreadID map, we break, we don't care. We don't wanna add it. And yeah. okay, that's good. And we cannot open testable target because we are debugging it. So we want to do that, and then compile. And this is EagleFly. And this is EagleFly. There you go. Alright. So now we assume that we can have any number of threads and IDs, and we just add it. So we don't have duplicates. We can have another one, but we don't want duplicates, and we just want valids. So that's nice. I like it. I like it. I like it. So we continue, create it. We have some exception point on there. Then we go and exit thread. Okay, so we're gonna exit the thread. Which thread am I going? We didn't even create the thread at all, isn't it? Or probably receiving a message from the past, which is hilarious. This is the ThreadID 25 303. Okay, it's the ThreadID is that, and I mean we don't have anything at all in the table, so we can go and let me see, don't get it. And we're gonna iterate through a whole place to find it, because we didn't look at it in the place and it was not. So probably we want just to we can look at the state ThreadID map and take a look. Let me see. I'll open it, and basically it's nothing there, it's nothing, so yeah, it doesn't matter. So probably we want to step out of it. Let me oops. Oh no, sorry. Yeah, okay. Okay. So now we get the buffer, and the buffer should be, since we don't have anything in the table, we don't have it, so it's okay. I mean, it's something that we didn't cache, but it has the ID there, and then we code 0. Okay, good. Thread blah, because we don't have it, exit the code 0. Okay. Okay. Okay, now we create the thread, which is what we were looking for, and we basically is valid, it's gonna be false, so we enter, and then is duplicate. We're gonna look at it, and the result is false, so it's not a duplicate. And we got it, and we go and we set it. Shall know which bucket was it. Bucket 1020-28. So we can do this, and there you go. We have the ID, which is this ID, and they handed to the thread, which is that, which is nice. We got it. We get it. We continue. We step out. We get it. We continue. F5, and that's it. Okay. So, yeah, I think that's good for today. Please, if you will ask some questions, feel free to ask them, and I'll be happy to answer them. For today, I think we said it good. It was some kind of tester more, and I mean, this is all about continuing to expand the functionality of the dispatcher, which for now, I mean, it's getting to take some kind of form. There's where we can see where, I mean, all the data that we were gonna need and how we're gonna process it and so on. So I think I like it. I like the way it's going. So yeah, I think that will be all for today. Thank you very much for coming, and I will see you all on the next stream.